So in this slide we have another snippet of my code, which is a while loop when time is less than 1.3 seconds. And in this one we have to apply Newton's second law, which is the final velocity of the ball here is equal to the initial velocity plus the net force divided by its mass, all multiplied by the change in time. And in order to have a constant velocity, we have to make the net force constant 0, so 0 in all directions. And that, in effect, cancels out the mass and this time. So, we have the final velocity is equal to the initial velocity. Woohoo! Now here is the actual full code that I used, and now we're going to run it knowing all that I've said already and see what happens. Alright, that's good. As you can see, it did, the ball representing the orange ball and from the tracker moves in the positive x direction for about, what I said, 1.2 seconds over the distance, and we get a nice linear graph which represents a constant velocity. So now you may ask, what if the ball moves in the opposite direction, the negative x direction? Well, there will be a couple changes. First, the velocity and the change in direction will become negative, and the second thing to change will be the motion versus time graph. However, the things that do stay the same is the change in time, which obviously cannot be negative, and the linear motion, it still remains just linear, but in the opposite direction. So in order for it to move in the negative x direction, I made a simple change and made the velocity to be negative, so indicating a negative x direction. So let's see what happens. And yes, the ball does move in the negative x direction, and the graph is shown with a negative slope, which also indicates a negative constant velocity. So, to summarize, what does this actually mean? Well, if the net force is equal to 0, then the velocity should be constant. And this is because all the forces acting on the ball are canceling out. So, theoretically, if the net force is not equal to 0, then the velocity should not be constant. And this imbalance of the forces should cause a different motion. So in order to give a visual example of a net force that is not equal to 0, I just changed the F net vector to a 0.2 net force in the x direction and 0.3 in the y direction. And the result should be very different from the previous example. Alright, as you can see, the path is definitely not linear. It's almost parabolic in shape, and that's because of the net force not being equal to 0.